So I'm just going to run through multiplying polynomials, and then tomorrow we'll look at multiplying polynomials but with quadratic functions. All right, remember we went through quadratic graphs, but now we're going to connect that quadratic graph with polynomials. But anyways, I just want to review this part. It says whenever I'm multiplying terms, and if the base is the same, bam, bam, then all I do is add the exponent. So it's x1 plus 2. So my answer is, I'd switch colors, but don't got time. X to the third power. That's multiplying. And then now briefly for dividing, x third divided by, you mean, would it be subtract, right? So since I'm dividing, this is x to the third minus 3. So my answer is x to the 0. Resume recording. This is one of the only times where the x to the 0, it matters. The only time we only put x is if it's x to the 1. But anything raised to the 0th power, all of it is equal to 1. So 2 to the 0th power is 1. The chair to the 0th power is 1. Y to the 0th power is 1. So anything to the 0th power is 1. If it was x to the 1, then I wouldn't have to put the 1. It would just be x. All right, so when we're dividing, we subtract the exponents. And when we're multiplying, we add the exponents. Keep in mind that this could be written in many forms. I could write it like this with parentheses. I could write it like this with the big dot. I could write it like the way I did it just now, x to the 1 times x to the 2. The same rules apply, but they'll oftentimes use different signs to trick people, because then it's like, what do I do now? All right, and same with the divide. All right, I could literally just have x squared divided by x squared, which this is equal to 1. Do you realize that why this is 1? Yes, but look at something else with this. Zoom recording. The whole thing behind it is x squared minus 2. And this is where we really start digging into why is stuff 1? People just think it's 1 because that's what we've always been told, but there's more to it. I'm going to stop recording, but that's just an overview of when we're multiplying polynomials. Actually, let's do one quick example. X squared times xy plus x. So then I'm going to do the distributive property. Let's get a different color. Bam, bam, distributive property. And then this gives me x squared times xy plus x squared times x. All I did was just write out each term with each term outside with each term inside. So then this right here becomes x to the third power y plus x to the third. And I can't really do anything else because they're not like terms. So that's my answer. Bam. It's fairly simple. Tomorrow we'll go over quadratic equations. This is a good time to review whenever you have free time before we start class tomorrow, what quadratic equations look like and what they are. All right, because then we're going to try and connect the quadratic equations with our polynomials and our graphing. So I'm going to stop recording now.